Water has shaped Melbourne's past, but what about its future? As climate change accelerates and Melbourne's population continues to grow, the way we source, treat, and use water must also evolve. In this episode, we explore the innovations and engineering strategies that will define the next century of Melbourne's water supply. Let's start with the challenge. For over 150 years, Melbourne's water system has relied primarily on rain-fed reservoirs, from Yan Yean and Maroondah to Thompson and Cardinia. These storages have served us well, delivering gravity-fed, high-quality drinking water from protected catchments. But the system's success is tied to climate, and that climate is changing. Scientists have confirmed a long-term drying trend across southeastern Australia is ahead of us. Since the 1990s, average inflows to Melbourne's reservoirs have declined by over 30%. Rainfall is becoming less frequent and less reliable, and with more intense storms and longer dry spells in between. In this environment, relying solely on rainwater is no longer sustainable. That's why Melbourne's water planners and engineers have pivoted from a model based on predictability to one based on resilience, diversity, and adaptability. Let's look at the technologies and strategies already reshaping our water future. First, desalination. Completed in 2012, the Victorian desalination plant near Wonthaggi marked a major shift in supply thinking. Unlike traditional reservoirs, desalination is a climate-independent source. It turns seawater into drinking water using reverse osmosis, removing salt, bacteria, and other impurities in the process. The plant can produce up to 150 billion litres per year, meeting around 30 to 35% of Melbourne's annual demand, depending on conditions. Water is transferred into the system via pipeline, blended with reservoir water, and distributed citywide. The benefits: guaranteed supply during drought, and a strong buffer against climate shocks. The trade-off: high energy use and upfront cost. That's why engineers today are now focusing on improving design efficiency, developing and utilising energy recovering devices, using renewable energy offsets, and optimising production cycles based on seasonal demands. Next, recycled water. Today, Melbourne reuses a portion of its treated wastewater for agriculture, public open spaces, industry, and toilet flushing. This is commonly known as Class A recycled water, and it helps offset demand on drinking water supplies elsewhere. But what about purified recycled water for drinking? Globally, cities like Singapore, Perth, and several US states already use advanced water purification to recycle wastewater into potable supply. These systems use a combination of ultrafiltration, reverse osmosis, UV disinfection, and rigorous testing to meet drinking water standards. Melbourne is actively studying this approach. It's technically viable, but will require public education, strong regulation, and long-term planning to build trust. If adopted, purified recycled water could add a major new supply stream into Melbourne's water portfolio. We're already changing how we interact with water at a household level and network level, with smart meters, leak detection sensors, and other network monitoring already being rolled out across Melbourne. These tools allow real-time data tracking, alerting utilities to leaks, bursts, and unusual consumption patterns. In some trials, smart metering has reduced household water use by up to 15%, simply by giving people better feedback and control. At scale, these tools could save billions of litres annually and reduce pressure on supply infrastructure. But supply isn't just about what we pump, transfer, and treat. It's also about what we capture. Stormwater has traditionally been treated as a nuisance, channeled away as quickly as possible. But today, engineers are working to capture, clean, and reuse stormwater in our cities. This includes projects like wetlands, biofilters, underground storages, and even pilot schemes exploring aquifer recharge, designed to intercept runoff, improve water quality, and store it for reuse. In newer suburbs, whole communities are being designed around water-sensitive urban design, where streets, parks, and buildings play a role in managing local water flows. Stormwater harvesting doesn't just provide an alternative water source, it also protects our waterways, reduces flooding, and improves urban livability. So, what does the future look like? It won't be built on a single solution, but on a diverse, integrated water system, one that combines climate independent sources like desalination and purified recycled water, smart, real time tools that optimize water use and leak detections, local water reuse through stormwater and rainwater harvesting, investment in green infrastructure that supports both ecology and supply, and community engagement and education which reinforces conservation culture. This is the vision of integrated water management, an approach that sees all urban water flows as potential assets, not problems. For engineers, this means thinking beyond pipes and pumps. It means working across sectors, collaborating with planners, ecologists, technologists, and communities. It means using data, modelling, and scenario planning to prepare for uncertainty. It also means designing infrastructure that's modular, flexible, and adaptive, able to scale up or down as the conditions change. And behind it all is a central idea. Water is not infinite, but it is manageable. If we plan carefully, invest wisely, and stay ahead of the curve. Melbourne's water story is far from over. It's entering a new chapter, one shaped by innovation, resilience, and long-term thinking. So there you have it. We brought this whole story together up to this point, reflecting on how Melbourne's water system has evolved since inception. The paradigm shifts initiated through historical droughts and through sudden growth periods, many then firmly reinforced by major environmental climate events, such as the Millennium Drought, and what it teaches us about planning and engineering for its future. I hope that when you turn on your tap at home or at work, you're able to reflect in a similar manner, or take steps in appreciating your own impact on this fascinating supply and treatment scheme. I'm Paul Michael Angus. Thanks for watching.